we have learned that displacement, initial velocity, final velocity, acceleration, time taken, all these terms are interrelated, and equations of motion describe the nature of relationship among these terms. So let us now derive the third equation of motion. For deriving the third equation of motion, we ignore time taken. We try to find out a relationship between displacement, initial velocity, final velocity, and acceleration. Now, equations of motion are valid only when the motion is in one dimension, that is, the body moves along a straight line, and if the motion is uniformly accelerated, that is, the value of A remains constant throughout. Now, when the acceleration is constant, we can say average velocity is equal to initial velocity plus final velocity by 2. So, we can write U plus V by 2. So, average velocity is equal to initial velocity plus final velocity by 2. We also know that average velocity is equal to total displacement by total time. So, total displacement can be represented as S and total time is T. So, S by T is equal to average velocity. So, we see that average velocity is given by U plus V by 2 and it is also given by S by T. So, we can equate these two terms. So, let us equate these two terms. We have S by T is equal to U plus V by 2. Now, we multiply T on both the sides. So, we get S is equal to U plus V by 2 and the T gets multiplied to this side. So, S is equal to U plus V by 2 into T. Now, from the first equation of motion, we know that V is equal to U plus AT. This is our first equation of motion. V is equal to U plus AT. From this, we get V minus U is equal to AT. V minus U is equal to AT. Or we can write T is equal to V minus U by A. So, from the first equation of motion, we get T is equal to V minus U by A. We can substitute this value of T here. So, let us substitute this value of T here. We get S is equal to U plus V by 2 into 40, we write V minus U by A. So, we have S is equal to U plus V into V minus U. We know that A plus B into A minus B gives us A square minus B square. So, V minus U into V plus U should give us V square minus U square by 2A. So, V square minus U square by 2A is equal to S. So, we can multiply both sides by 2A. Multiplying by 2A, we get 2AS is equal to V square minus U square and we can write it as V square minus U square is equal to 2AS. And this is our third equation of motion. So, V square minus U square is equal to twice s. This is our third equation of motion. So the third equation of motion is a relation between acceleration, initial velocity, final velocity, and displacement. Given any three of these terms, we can use the third equation of motion to find the fourth one. Now we are given that displacement is equal to 700 meters, initial velocity is 2 meters per second, time taken is 10 seconds. Can you find the value of final velocity using the third equation of motion? Well, the third equation of motion is v square minus u square is equal to 2as. We have to find the value of v here. We know the value of u. We know the value of s. But we do not have the value of acceleration. So we cannot use the third equation of motion to find the value of final velocity when we are given these values. So the correct answer is no. So let us now derive the third equation of motion by graphical method. This is a velocity time graph. Velocity at time t equal to 0 is u. So the initial velocity is u. Total time taken is t. So time taken is t. Velocity at time t is v. So the final velocity is v. We denote displacement by s and acceleration by a. Note that this velocity time graph is a straight line, hence it represents constant acceleration. Now we know that magnitude of displacement is equal to area under the velocity time graph. So we can use this velocity time graph to calculate the magnitude of displacement. What will be the area under this graph? This is the area under the velocity time graph. And this area gives us the displacement. So this area gives us the magnitude of displacement. Now this is the area of region OCAB. And what is OCAB? OC is parallel to BA. So two sides are parallel, and since we have two sides as parallel and this is a quadrilateral, hence OCAB is a trapezium. So area under the velocity time graph is equal to area of trapezium OCAB. Now how do you calculate the area of a trapezium? Area of a trapezium is equal to half into altitude into sum of the parallel sides. So we get the magnitude of displacement, which is S, is equal to area of this trapezium, which is half into altitude. What is the altitude? Altitude is the distance between the parallel sides. So OC and BA are the two parallel sides, and the distance between the parallel sides is this, which is OB. So OB is the altitude of this trapezium into sum of parallel sides. So what are the parallel sides? OC and BA. So the parallel sides are OC and BA. So this is the area of trapezium. This is equal to half into what is OB? OB is this distance. This is equal to total time taken, which is T. What is OC? OC is this distance. This is initial velocity. And what is BA? BA is this distance. So this distance is equal to this distance, which is final velocity. So S is equal to half into T into U plus V. Now from the first equation of motion, we know V is equal to U plus AT. V minus U is equal to A into T, or T is equal to V minus U by A. So T is equal to V minus U by A. So let us substitute this value of T here. On substituting this value of T, we get half into V minus U by A into U plus V. So this is what we get. Now let us simplify this. V minus U into U plus V. We know that A plus B into A minus B gives us A square minus B square. We have 2A in the denominator. So let us multiply both sides by 2A. We get 2AS is equal to V minus U into V plus U is V square minus U square. So 2AS is equal to V square minus U square. Hence, we get V square minus U square is equal to 2AS. And this is our third equation of motion. So we have derived the third equation of motion, V square minus U square is equal to 2AS by a graphical method using a velocity time graph and by finding the area under the graph, that is by finding the area of this trapezium. This is a relation between final velocity, initial velocity, acceleration and displacement. So let us solve a numerical. A car is moving with a velocity of 80 meters per second. The driver applies brakes to produce a uniform acceleration of minus 2 meters per second square. How far will the car go before it stops? So first, what information do we have? A car is moving with a velocity of 80 meters per second. This means that the initial velocity is 80 meters per second. Now since it is given that it is moving with uniform acceleration, we can use equations of motion. So acceleration is minus 2 meters per second square. And how far will the car go before it stops? So we need to find the displacement. What is the third equation of motion? It says V square minus U square is equal to 2AS. So we have U here, we have A here, we need to find S. What about V? V is not given anywhere in the question. Read the question carefully. How far will the car go before it stops? It stops means that the final velocity of the car is 0 because the car has stopped. So the final velocity is 0. So now we have V, U, A and we want to find S. We can simply substitute the values in the equation and calculate. So V is 0, 0 square minus U is 80, 80 square is equal to 2 times A is minus 2, S. So 0 minus 80 square. Minus 80 square is minus 6400 is equal to minus 4S. So S is equal to minus 6400 divided by minus 4 meters, which gives us 1600 meters. So this is the final answer. So we have seen that third equation of motion is equal to v square minus u square is equal to 2as. It gives the relation between initial velocity, final velocity, acceleration and displacement. And using this equation, if we are given any three of these terms, we can find the fourth one.